So this question wants us to take the word equation and turn it into a balanced formula equation. So in order to do this, we need to get the formula for sulfuric acid. Hopefully we remember that is H2SO4, and then missing from here is copper sulfate, which is CuSO4. In terms of balancing it, the actual equation is already balanced. You can check it using the methods we've practiced in class. There are 2 marks. There's 2 marks, 1 mark here, and 1 mark for this part. Next one, calculate the relative formula mass. So all we've got to do here is there is 1 atom of copper, and copper we can see here is 63.5 times by 1, which is 63.5. We've then got carbon, and there is 1 of them. So that is carbon's mass is 12, times it by 1, that's going to be 12. And then we have got oxygen, and there are 3 oxygens in there. So I've got 3 times the mass of oxygen is 16. So that's going to be 48. So we add those up. Let's put those into my calculator. Plus the 12 plus the 63.5, I've got an answer here of 123.5. 2 marks in total, 1 mark if you've got all these bits, and then 1 mark for the final answer. Next one, which is a test for carbon dioxide. So carbon dioxide, if you remember, we bubble it through lime water, and the lime water turns cloudy. That's a bit of core knowledge for you. So that is option A. And then we have got experimental setup showing they are reacting copper carbonate with the acid. The copper carbonate is added until the reaction has finished. How would you know when the reaction is finished? Well, this reaction, as you've seen, produces carbon dioxide gas. So one thing you would see indicating the reaction is finished is there would be no further fizzing, because the acid no longer will react with the carbonate. The other thing you would see as well is that the copper carbonate would remain at the bottom of the flask. At the bottom of the flask, unreacted. So it's insoluble, we drop it in, and it wouldn't react anymore, and therefore remains at the bottom of the flask, unreacted. Okay? Last little one, we've got carbon with oxygen, and it wants us to draw the dot and cross diagram for carbon dioxide. So the way we're going to do this is putting these in. There is a video that shows you how to work out the actual structure if you are unsure, but that's what we should have. The marks for this are going to be awarded for 1 mark if you've got the electrons correct in here. So you get 1 mark for these bits, and then you get a 2nd mark if you've got the number of electrons in the oxygens correct as well.